Hi, welcome to my YouTube channel Education for Aspirants. Today I am going to discuss the different turning methods used in AVL tree. In this lecture I will be covering how to find out the valence factor of a node in the tree, then the concept of AVL tree, and at the end we will discuss different rotation methods used in AVL tree. The prerequisites for learning this concept is the concept of binary search tree. AVL tree is the extension of binary search tree. So if you know the concept of binary search tree, then easily you can understand this. Let's start the session how to find out the balance factor of a node inside the tree. So what exactly the balance factor is? Balance factor of a node is a value which represents the difference between left height and right height of a node inside the tree. So what is left height? The maximum path covered to reach at the last leaf node from the respective node in the left side. That is called as left height of the node. Similarly, what is the right height of the node? The maximum path covered to reach at the last leaf node from the respective node inside the right side. That is called as right height of the particular node. So in this way, if you will calculate the left height of 20, you can see here to reach 14, the total path is 2. Similarly, to reach 18, the total path also covered 2. So left height of 20 equals to 2. Similarly, what is the right height of 20? So to reach 22, what is the maximum path covered? 2. Similarly, to reach 20 to 28, what is the maximum path covered? 2. So right height of 20 is also 2. So what is balance factor? The difference of left height and right height value of a node represents as balance factor. If we calculate the balance factor of 16, we need to consider the left height of 16 as well as the right height of 16. What is the left height of 16? 1. What is the right height of 16? 1. So 1 minus 1 equals to 0. So balance factor of 16 equal to 0. Similarly, balance factor of 24 equal to how much? Left height is 1, right height is 1. So 1 minus 1 equal to 0. Similarly, 14 balance factor is 0. Why it is 0? There is no left child, there is no right child. So that's why 0. The balance factor of leaf nodes are 0. Why? Because leaf nodes that doesn't have any left child and right child. That's why their balance factor is 0. Now we'll switch over to what is the concept of AVL tree. A binary search tree T is said to be an AVL tree if the balance factor of each node inside the tree is in the range -1 to 1. So what is the meaning of -1 to 1? Meaning of -1 to 1 is either -1 or 0 or 1, right? But if the balance factor of a node exceeds from -1 to 1, then what will happen? That node is called as imbalanced node. As per the definition, imbalanced nodes cannot be possible inside the AVL tree. The second definition, we can say a height balanced binary search tree is said to be an AVL tree. So guys, normally we can consider the AVL tree is the extension of binary search tree. Means what we have done in binary search tree, the same thing we will do in the AVL tree at the time of insertion and deletion. Let's see this binary tree structure. So we will calculate the balance factor. What is the balance factor of 20? 20 balance factor is left height is 1 and right height is 2. Clear? 1 minus 2, that equal to -1. What is the balance factor of 16? 0 minus 0, that equal to 0. Similarly, what is the balance factor of 23? 0 minus 1, that equal to -1. Similarly, what is the balance factor of 24? 0 minus 0, that equal to 0. Why it is 0 minus 0? Because there is no left height, there is no right height. That's why 0. Now, imagine if I will insert another node inside the binary search tree. For example, let I will insert 26. If I will insert 26, as per the rule, 26 will come the right side of 24 because it is greater value from 24, hence it will come in the right side. After insertion, you calculate the balance factor. If you will calculate the balance factor of 16 will not change, but the balance factor of 20 will change. How? The right height of 20 become 3, but left height is how much? 16. So what is the new balance factor of 20? New balance factor of 20 is 1 minus 3, that is -2, right? What is the new balance factor of 23? That is 0 minus 2 equal to -2. Why -2? Because right height equal to 2. Similarly, what is the new balance factor of 24? 0 minus 1, that is minus 1. Clear? After insertion of 26, if you observe now, the balance factor of 20 got imbalance. How? Because the balance factor of 20 exceeds its range, that is minus 2. Hence, that is called as an imbalance node. That type of imbalance node is not possible inside the AVL tree. If such type of imbalance node will come, we need to follow different rotation method to make that imbalance node into a balanced one. Now we will switch over to different rotation method. In AVL tree, there are 4 different type of rotation methods we are using. One is right to right rotation, that is termed as right right. Similarly, right to left rotation, that is termed as right left. Left to right rotation, that is termed as left right. And left to left rotation, that is termed as left left, that is LL. So there are 4 different type of rotations. One is right right, second is right left, third one is left right, and fourth one is left left. Clear? So we will use one of the rotations among these 4 rotations to make a imbalance node into a balanced one. Now we will switch over to different rotation methods. So first we will discuss right right rotation. In this example, 20 and 24, now it is balanced. Balance factor of 24 is 0 and balance factor of 20 is minus 1. After that, let I want to insert one more element into the binary search tree. Let us consider 26 I will insert. After insertion of 26, the balance factor of previous nodes will change. See what is the value? What is the new value now? 26 balance factor equal to 0. 24 balance factor is 0 minus 1, that is minus 1. Similarly, 20 balance factor is 0 minus 2, right? That equal to minus 2. So now after insertion of 26, the 20 node got imbalance, right? So you need to apply some rotation method to make it balance. So from this 4 rotation method, how will you decide what type of rotation method you will apply here? To decide what type of rotation method, so just check what is the node got imbalance and due to which node that node got imbalance. These 2 things you need to find out here. So what is the imbalance node here? 20. Due to which node that 20 got imbalance? 26. So now find 26 present in which side of 20. Then this will give you the idea which type of rotation you will apply. So see here, in which side 26 present. To find out the which side, you start moving from the affected node towards the caused node. So this is, if you come like this is right and this is also right. Means you can confirm that here that caused node present in the right to right side of that affected node. Hence the turning is right to right turning. In right to right turning, you will make the center node as root node and you will turn the affected node into the left side. See here in this figure, 24 becomes root node and I made 20 as left turn. So that's why 20 becomes left child of 24 and 26 as it is. So after rotation, you calculate the balance factor. 24 balance factor is 0 because left height is 1, right height is 1. 20 balance factor is 0. There is no left height, there is no right height. 26 balance factor is also 0 because there is no left height, no right height. I hope understood. That is an RR rotation. Then RL rotation. In RL rotation is called as right left rotation. So see here in this figure both the nodes are balanced. How? Because 20 balance factor is minus 1 and 26 balance factor is 0. Now I will insert a node into the left side of 26. Now calculate the balance factor. 24 balance factor is 0. 26 balance factor will become 1. How it becomes 1? 1 minus 0. 1 means left height is 1, right height is 0. 1 minus 0, that equal to 1. Similarly, what is the balance factor of 20? The left height is 0, right height is 2. 0 minus 2 equal to minus 2. Now, after insertion of 24, the balance factor of 20 got imbalance. So, how will you decide what type of turning? Just check 24 present in which side of 20? That is right and left, right? That's why the turning is called as right-left turning. And as per the rule of right-left turning, you will make the lower node as root node, then the middle node don't disturb to it, and you will turn to the affected node into the left side. See here, I made 24 as root and 20 turn to the left side of 24, then 26 as it is in the right side of root node. And after turning, calculate the balance factor. This is 0, this is 0, this is 0. Why it is 0? Because left side 1, right side 1. That's why 0. Left side, there is no left side, there is no right side. That's why 0. No left side, no right side. That's why 0. This is all about your right-left rotation. Then come to left rotation. In left to left rotation, so this is the binary search tree where both the nodes are balanced, right? So if I will insert a node in the left side of 16, after insertion calculate the balance factor. Balance factor of 14 equal to 0. Balance factor of 16 will become 1 minus 0. New balance factor of 16 will become 1. Then what is the new balance factor of 20? That will become 2 minus 0 equal to 2. So after insertion of 14, the balance factor of 20 got imbalance. Now you need to make a turn. So which type of turn you will apply? To decide this, you find 14 is present in which side of 20? That is left, and here also left. 14 is present in left of left side of 20. That's why the turning is called as left turning. And as per the left turning, what you will do? You will make the middle node as root node, then you will turn to the affected node into the right side of root node. So as per the left rotation, make the middle node as root node and turn to the affected node into the right side of root node. Clear? So 16, right of 16 is 20, 20 was the affected node, then 14 as it is in the left side of 16. Calculate the balance factor after turning. Balance factor of 14 is 0, 20 equal to 0 and 16 equal to also 0. Now we'll move to left-right rotation. In left-right rotation, see here, that is the binary search tree, and here calculate the balance factor. 26 balance factor is 1, and what is the balance factor of 20? 0. Now I will insert a node in the right side of 20. After insertion of that node, calculate the balance factor. The new balance factor of 24 will become it is 0. The new balance factor of 20 will become left height is 0 minus right height is 1, that equal to minus 1. Similarly, what is the new balance factor of 26? Left height is 2, right height equal to 0, that equals to 2. Now after insertion of 24, the balance factor of 26 got imbalance. So you need to make a turn. So find 24 present in which side of 26? That is left, then this is right. So what is the turning? Left-right turning. And as per the left-right turning, the lower node will become the root and you will turn to the affected node into the right side of root. So see here, I made 24 as root, 20 as it is left side, and 26, that was the affected node, made it right side. And after turning, calculate the balance factor. This is 0 and balance factor of 20 equal to 0, balance factor of 26 equal to 0. So this is all about your left-right rotation. Then come to another example. When a single node will got imbalance, then what type of rotation you will apply to make the imbalance node into balance? So we have discussed. But imagine if in a situation multiple nodes will got imbalance after an insertion, then at that time how will you decide which imbalance node you will first apply for the turning? That is important. So see here, in this example, before insertion, now this tree is balanced one. How? Because 20 balance factor is minus 1, 16 balance factor is 0, and 24 balance factor is 1, and 22 balance factor is 0. Means all the nodes are got balanced. Now I will insert 23 in the right side of 22. After insertion of 23, the balance factor of 23 will become 0. Balance factor of 22 will become minus 1, right? Balance factor of 24 will become 2 minus 0, that equals to 2. Similarly, the balance factor of 20 becomes 1 minus 3 equal to minus 2. I hope understood. So after insertion of 23, you can observe here the balance factor of 20 as well as 24 got imbalance. Means two nodes got imbalance. If two nodes got imbalance, then how will you decide which node you will make balance first? That you need to decide. So for that purpose, what you will do, you just move towards the root node from the inserted node. Then at the time of moving, which node will come first? You first make turn to that node. Then after turning to the node, you check whether it is balanced or not. If tree is still imbalanced, then again you apply the turning to the rest of the nodes. So in this case, we will first apply turning to the 24 node first. So to make turning 24, we require serially 3 nodes, right? So you just consider these 3 nodes for the turning. So if you turn to these 3 nodes, then after turning, you will get the figure like this. See here. So this is which type of turning? 24, 22, 23. Which type of turning? That is LR turning, right? As per the LR turning, you will make the lower node as root. See, I make the lower node as root, 23 root, 22 left side, and I turn to the 24 into the right side. See, I made 24 as a right node. Then after turning, you keep the rest of the nodes as it is in the tree. So this is your final figure. Now calculate the balance factor. 20 balance factor, left height is 1, right height is 2. 1 minus 2, that is minus 1. 16 balance factor, 0, 0 minus 0, 0. 23 balance factor, 1 minus 1, that equals to 0. 22 balance factor, 0 minus 0, that is 0. 24 balance factor, that is also 0. Now you can observe here all the nodes are balanced. I hope all of you guys you understood the rotation methods clearly. And in the next lecture, we will discuss how to insert an element into the AVL tree. Thank you.